Hello everyone and welcome back for a new video. Today we're gonna keep talking about TypeScript, and in particular I'm gonna talk about type narrowing. Type narrowing is when we want to have a strict type of check for different conditions. For example, we can have a function that can accept parameters of mixed type. Simple case could be strings and numbers, and we want to be able to use the right methods with input and string. So let's have a look at what happens when we do so. So let's say we have a function, call it my function, and we have input that can be a number or a string. Let's do the text a little larger, it's too much. So what happens when if I'm gonna try to use this value, this input value, TypeScript is gonna give me just the values that are available in both methods, so in both number and string. So what I wanna do here, I wanna be able to determine which type I'm working on. And how can we do that? Well, in this simple case, we can use the native type of, and if we do if type of input is string, then we can apply all the string methods that appear in that we have available for a string. So we can, for example, do a replace, and we replace all the white spaces with an underscore. Okay, what about, and we just return else? Here, this number, because it can only be a number or a string, is gonna just return me the methods for number. So input.toPrecision, and now this function is exhausted completely. So what we could do here, when we do a type narrowing, we tell TypeScript to take the type of operator of the parameter in input, and we check the type, and then we can apply TypeScript and correctly infer what are the types. However, there is a catch. The type of operator native to JavaScript can only give us value like string, number, big int, boolean, symbol, undefined, object, and function. And this is basically how regular JavaScript works. But there is an issue. If we have a value of type null, if we do console.log type of null, this expression is actually going to return us object. So what does it mean? It means that if you're gonna have a function that takes a null parameter or an object, for example object, and then we give an input, and the input is an object that has a shape like item is a string or null. Now what is gonna happen when we're gonna use the type, the same structure that we followed before? Item, as you can see, doesn't give me the access. Sorry, I cannot do input.item. It's gonna give me an error because the object could be null. Because of what we saw before, that type of null is gonna return object anyway. So here we can use another built-in feature of JavaScript, and we can narrow it down by doing input, and we check if it's a falsy value. So as you know, null is a falsy value. So if input is not a falsy value and the type of input is type object, then input.item is available. So in this case, instead we are dealing with null. Here we are actually dealing with a null. Another built-in way for JavaScript to check an input of being of a certain type is to check if a type is an array. So to check if a type is an array, we can do string or array, and we give our input, and the input is of type string or of type string array. And now to check it, what we're gonna do is if array.isArray, this is gonna return true if the input parameter is exactly of type input. So we can do input dot all the various methods that are applied to an array. So given that we have a string, we can do hi, hello, else, because here we know that the input is of type string. So these are all bundled in with JavaScript. Now, the next bit we can use to narrow the type is to have a look at what can happen if we use the in operator. The in operator is native with JavaScript and is able to understand if inside an object there is a certain value. So let's say we have an object, we have a const my object, and the values are name, my name, age 12, no, let's do it, age 23. Let's put a couple of values that are falsy. So we have an address which is undefined, and we give it a second name which is null. Now we want to determine if a certain parameter is inside my object. For example, we want to check if my object has a property called surname. So we can do has surname, which is not in the object right now, I'm aware of it. Surname in my object. And now this one is going to have a value of, this is going to be false because of course, because this value surname is not in the keys of the object. Then the other one we can check. The reason why I put those values in there is that I'm gonna check if I have an address, a second name, and what is gonna happen in those cases. Const has address is equal to address in my object. So what do you expect in here? So what we expect is that when I check if I have a surname, this should be false. Address should be true because actually I have a key called address in my object, and I have a key called second name with an underscore in my object, so this other one should be true. So we should log, the final log that we should obtain should be true for has surname, false, and true for has address and has second name. Okay, so now let's see what happens if we try to use it. If, let's say, has address, my object dot address dot, we can assign const x equal object on my address, and now we say to TypeScript that this one is actually type string. And now TypeScript has inferred that undefined, which is the value of object in my address, although as address is true, TypeScript correctly inferred that as address is actually undefined. So here we can do a null collection operator and give it an empty string, and that's gonna make TypeScript happy. And the exact same is gonna go for has second name. So if has second name const y string is equal to my object dot second name, and it's gonna complain because it's actually null. So we cannot assign null or undefined to one of type string. Okay, so let's have a look at the next built-in operator for type narrowing that is in JavaScript. And this one is the last one we're gonna see. Then the following ones are gonna be using the power of TypeScript itself. The next one is gonna be the instance of operator. So the instance of can determine if an object was created as an instance of a certain class. Now, it can be a custom class or can be a built-in JavaScript class. So let's say we have a function similar to the one I wrote at the beginning, but instead of taking a function, my object function takes an input, and the input can be of type date, can be of type string with a capital S, or can be of type string, so a regular type string object. And now if input is instance of date, then we can do input dot to UTC string. Else if input instance of string, then the input was of a string class. Actually, I'm gonna put some console log. And now in the else case, all that is left, input was a regular string. So if I call my object function with new date, my object function with new string hello, and here we just pass a regular string, what we're gonna obtain, I'm gonna put get full here, just so we can run this. And the first log it's instance of date, instance of type class, and was a instance of a regular string using the instance of operator. Okay, the next bit we are gonna see, the last bit we're gonna see for today's video, are type predicates and discriminated unions. So essentially what we want to do, we want to have a way to inform TypeScript about a certain type and how such type can make use of type predicates. So we have an interface, and let's set this interface as a name and the name of a product. So let's say we produce windows and glasses. So this is an exterior window, or we have a glass. I'm not using the window here because essentially what happens is that it will conflict with the regular window. So this is gonna make things a little bit easier. Interface, I need to my interface, and now this one is gonna have a price of type number. Then I'm gonna have instance interface exterior window, which extends from my interface, and the exterior window has a name of exterior window, as a width, as a length, and we have a double glazing of type boolean. Then we have an interface class that extends my interface, and the name in this case is gonna be glass. Then as a capacity, for example, milliliters, and we can have a like don't know, height or color. Okay, now I want to have a function that consumes this object, const consume glass or window, and this one takes an object, and the input can be of type glass or of type exterior window. Now here, if is glass, we need to have a way to tell if the input is of type glass or of type exterior window. So how do we do that? We can do something called type predicate. So to do a type predicate is a function that I'm gonna write in here. If is glass input, then input is of type glass, else if is exterior window, and then here input is of type exterior window. So shall we write those functions? So how do we do this? Const is glass, take as an input an object which can be of type glass or of type exterior window, and the return type is that it tells if object is glass. That's the actual syntax. So return object dot name and is equal to glass. So now if you go inside this function here, input gives me all the parameters that I have available if I'm dealing with a glass, and now I can do essentially the same for is exterior window, but with the difference that here I'm gonna check the name is exterior window. So now here I know that I'm dealing with an exterior window. So input, I'm gonna put input input in here. It's because the return type here was wrong, is exterior window. So here input dot double glazing, and then we can put an else, and the type that you saw while I was doing this mistake in here is that input is of type never, meaning that this section it's a condition that should never happen, and TypeScript has it as a never type. So this is everything for today's video. I hope you enjoyed. If you did, please leave a thumbs up, and see you on the next one. Take care, bye bye.